Let's do one more problem. Now, the problem with the working gas law problems like this is we can mix it up. So we can have three of any of these four quantities and go after the last one. So let's see what we got here. So it says what volume will, so I'm going to find volume, I'll put question mark, 0.20 grams of carbon dioxide. Now, I very rarely in Intro to Gen Chem give you information problem that you won't need to use. So can you see where actually I can use this grams of carbon dioxide to get to moles? We've been doing a lot of that. So actually I'm going to put that under my moles. So here under N, I'm going to put 0.20 grams of CO2 to get to moles. I hope that works for you. Would occupy a pressure of 732 millimeters of mercury. So pressure is 732 mmHg, millimeters of mercury, at a temperature of 22.0 degrees Celsius. 22.0 degrees Celsius. Now we do have some fixing up to do. So for instance, let's see, if we use the R value we're using, actually, do you know what units millimeters of mercury have to be, what units of pressure need to be in? They can't be in millimeters of mercury. Units of pressure needs to be in units of atmospheres. Do you remember the relationship between millimeters of mercury and atmospheres? It's an exact relationship. As it turns out, 1 atmosphere is exactly equal to 760 millimeters of mercury. So we're going to use that actually. Let's see, and we already said that N, we're going to have to do some fixing. We're going to have to come up with the molar mass of CO2 and use grams mass and molar mass of CO2 to get to moles, right? Let's see, what about temperature? Well, temperature units need to be in units of Kelvin. So we have some fixing up to do. See how that goes. Just to kind of review then, as long as our as long as our N is in moles, temperature is in Kelvin, pressure is in units of atmospheres, what will our volume be? Our volume will be in units of liters. Exactly. Here we go. So let's go ahead and rearrange this solving for volume. So in this case, I divide both sides by pressure and I get this relationship. I say volume is equal to nRT over P. And then I'm ready to kind of plug into my nRT over P. So let's go ahead and knock out N, if that works, if that's okay with you. We have usually a gas, you don't care what the identity is, but we need the identity in this case to go from mass to moles using the molar mass of CO2. We need its identity to get the molar mass. So from the periodic table, this represents carbon, this represents oxygen, and here's the molar mass. Now remember, we're going to use that as conversion factor. So our first term actually is going to be that 0.20 grams of CO2 over 1. What's our next term going to be? Well, if we want grams to cancel, be left with moles, it's going to look like this. 1 mole over 44.01 grams. So grams cancel, we have units of moles. How many sig figs do we round it to? We round it to 2 sig figs. So I get 0.0045 moles. That's going to be what? Our N, right? All right. Well, what else do we need to fix? We need to fix temperature. Now, if you're given Celsius, we add 273.15. You know, if you're in doubt with how many sig figs or how many, decimals we need to leave for the thing we add to it, just go ahead and go with 0.15 and you can't go wrong. We round according to 1 decimal. And we have our temperature term is 295.2 Kelvin. The last thing we need to fix is our pressure. So remember, whoever did this gave us the gas pressure in millimeters of mercury. And I said that 1 atmosphere is exactly equal to 760 millimeters of mercury. So how can I use this equivalency statement as a ratio to get millimeters of mercury to cancel, be left with units of atmospheres. Yep, we're going to put units of millimeters of mercury in the bottom, units of atmospheres on top, and it looks like this. Now, when you're rounding using this equality like that, remember that this is an exact relationship, so this brings no uncertainty. So how many sig figs do we allow in our answer? 3 sig figs. Very good. And so this then actually is your pressure now in units of atmospheres, 0.963 atmospheres. So by my count, we've got everything we need to go ahead and substitute in. Let's see what that looks like. So our volume is equal to number of moles times the R times temperature divided by pressure. Let's see what units cancel. Moles have canceled, units of Kelvin cancel, and units of atmosphere cancel, leaving us with units of liters. I really strongly urge you to do this kind of, it's called dimensional analysis, to go ahead and let things cancel and make sure that you're getting the units that you should have, which is great. So how many sig figs are we going to allow in our answer? I'm liking 2, and actually we're limited by these 2 sig figs here. Remember, those zeros are important. They're placeholders, but they're not significant. And we said we had 5 here in this ideal gas law constant. We have 4 again here in the temperature, and I'm liking 3 sig figs here in the pressure. So we're going to go round it to 2 sig figs. Dun dun dun. Did you get a volume of 0.11 liters? So as long as the gas is behaving, the CO2 gas is behaving ideally, that mass at that pressure and that temperature would have a volume of 0.11 liters. Just so cool. I just think it's neat. It's a beautiful thing. So these problems are associated with this work. Don't forget that this semester anyway, I've got hints available for you to click on to help kind of give you hints.